See this question. This is taken from Navate book exercise question. So consider the relation for the published books, which means they have given a table and then they have given the FDs. Now they are asking us to break it into a third normal form. I'll just read out all the attributes of the book here. The relation. So the attributes are book title, author name, book type, list price, author FL, and publisher. And the relation name is book. The table name is book. Okay. And they are saying that author FL, which means here they have given author FL, one of the attribute, refers to the affiliation of the author, just the meaning of the attribute. And then they are saying that suppose the following dependencies exist, which means these are the dependencies they are saying. So one dependency is book title can determine publisher as well as the book type, and book type can determine the list price, and author name can determine author FL. Now given these three functional dependencies, you are supposed to decompose the table into third normal form. So we shall go in the same procedure. Even though we have to decompose the table into third normal form, we are going to first decompose into second normal form and then get into the third normal form, right? So we shall do it this way. So before going ahead, since these names are very big, you can just replace them with some small variables. So let us say a book title is represented by B, and author name is represented by A, and book type is represented by BT since B is already taken, and list price is represented by L, and author FL is represented by AA since A is already taken. Let's not take AA, you might feel that it is A again. So let's say AU, and publisher is P. So what is our table going to be? I'm just trying to write it in using small abbreviations so that it will be easy for us to work on them. So book is going to be B, A, BT, L, AU, P. So this is the book, this is the relation, and these are all the attributes. What about the FDs given? FDs given are like this: book title BT determines publisher, comma, book type. So book type is given as, for book title we have taken B, isn't it? So for book title we have taken B, represents, determines publisher, which means P, and book type. For book type we have taken BT. Okay. So instead of B and BT, instead of taking it like this, it is confusing. Let's take ABC and XYZ. That way it will be easy. Okay. So let us say, instead of taking this, let's use some names, convert everything to some other variables. Let us say this is A, this is B, this is C, this is D, this is E, this is F. This way it will be easy. Okay. Now the book will come. Now if that is the case, let's try to write these functional dependencies also in terms of those variables. Now book title is going to form A, and publisher is going to form F, and book type is going to form C. Similarly, book type is C and list price is D, right? And author name is B, and author FL is E. Got it? So now what is the table? The table is going to contain, the book is the table, or the relation, it is going to contain A, B, C, D, E, F, right? And the functional dependencies are going to be A determines FC, C determines D, B determines E. So in the exam also they are going to give you this way, so you better follow these conventions, then it will be easy for you to answer them. Okay. Now we have to find out in this given table what could be the candidate key. So what is the simplest way of finding out the candidate key? Find out all the attributes which are not present in the right hand side of the FDs. Now if you see this, F is already present, C, right? And because of C is already present, D present, E is present. Now what are not present in the right hand side? A and B. Therefore A and B should definitely be present in the candidate key. It is a necessary condition, right? Okay, A, B should be present. Now let me see if A and B are sufficient to become a candidate key. So how can I say it? AB plus. Now if I find out AB plus, it is going to be AB, and because of A it is going to be FC, and because of B it is going to be E, and because of this dependency is already there, D. Yes, I am able to get all the attributes by finding out AB. Now see this, AB is the necessary, they are necessary in the candidate key as well as they are sufficient, right? So what does it mean? You cannot take out either A or either B, so it is the minimal key, and also no need of adding any more attributes. Therefore this is the only candidate key. If you try to add anything, it is going to make up to super key, right? Therefore this is the only candidate key we are going to get. Now once you decide upon the candidate key, you can distinguish the attributes, FDs, whether they are going to give us partial dependencies or not. Why are we doing that? To check whether the table is in second normal form. Okay. Now if you see this, the first functional dependency, the left side is part of the candidate key, therefore it is definitely partial dependency, right? And the second one, C determines C, C determines D, left side is not the part of the key, right? Therefore it is not partial dependency. Third one, if you see it, left side is the part of the key and right side is the non-key, right? Here also right side are the non-keys, therefore it is definitely partial dependency. So we got two partial dependencies. So whenever we get partial dependencies, find out the closure of the left side, this one, and split the table. Now if I try to find out the closure of A plus, then I am going to get A, and then because of A, FC, and because of C I am going to get D. That's it. So this is going to be A plus, right? Therefore take the original table, and from that original table you split out this table. So which means A is going to take with it, one is F, other is C, and other is D. Got it? And there is one more partial dependency, B determines E. Now if you see this, B determines E, find out B plus. B plus is going to be simply BE, nothing else, right? If you find out B plus, you are going to get BE. Therefore B, you take it, you make it a different table, so B is going to take with it E. Got it? Now what is remaining? Only A and B, so leave them in the original table, or like this. So now we are going to get three tables, 1, 2, 3. And what are the functional dependencies applicable on each one? On the first one we are going to get A determines FC and C determines D. On the second one we are going to get B determines E. On the third one we are going to get, okay, that is the actual combination that we had kept. The table we just formed so that in order to merge them losslessly. Okay, when you want to join the tables, we are going to use this one so that we do it without any loss. Now in this table, this is the primary key, and in this table this is the primary key. So since the primary keys in these two cases are single attributes, there is no way we are going to get partial dependencies. Now let's try to see whether we can get any transitive dependency or not. Now in this table there is no way we are going to get transitive dependency because there is only one non-prime attribute, right? Here also there are no non-prime attributes and no FDs, so there is no way you are going to violate any normal form. Now if you see this, there are three non-key attributes, so there is a chance that there might be a violation. Now if you see this dependency, C determines D, it is a dependency between two non-key attributes, so definitely that is a violation of third normal form. Why? This is a transitive dependency. So this is a transitive dependency. Now what should we do? Find out C plus and split the table. If I find out C plus, I am going to get CD. Therefore I have to split this table further into two tables. Now if I find C plus, it is going to be CD, which means C is going to take with it the D attribute. Got it? And whatever is remaining, let it be there. A, F, C. Right? Now what is this? A is the key for this, C is the key for this, and the intersection is C, which is the key for this. therefore lossless. That is why I have to leave C here as well. Got it? Okay, now if you see this, we got I think 4 tables. One table is this, other table is this, other table is this, and this is the 4th table. So we got 4 tables, and this dependency is applicable on this, and this particular dependency A determines FC is applicable on this, and C determines D is applicable on this. So all the functional dependencies are also preserved. So if you see this table is in third normal form because there is only one non-key attribute, there is no violation, and also there is no partial dependency. And if you see this, there is no transitive dependency, right? And also one key is there, one single attribute is there in the candidate key, therefore there is no partial dependency is possible. So third normal form. And what about this? Third normal form, third normal form. So all these 4 tables are finally in third normal form, and also we decompose them in such a way that lossless is preserved and also dependencies are preserved. Got it? Okay.